pressure. So pressure, how we define the pressure? Pressure is the force acting on unit area. So how much the force act on a unit area or specific area, that is known as the pressure. So if we want to calculate the pressure, pressure is F by A. And what about the unit of the pressure? The unit of the force is Newton, the SI unit, and the unit of the area is meter square. So it's Newton per meter square. And Newton per meter square is also known as Pascal. So we can say pressure, like we can write as Pascal, or we can also write Newton per meter square. And pressure experienced by an object depends on the force which it exerted by the object or on the object, and it also depends on the cross-sectional area. If we have a small cross-sectional area for a constant force, the pressure will be high. If we have a constant surface area, the large force, if a large force is applied on the object, it will experience a greater pressure. The pressure exerted by the object, like example, if I say there is a container which is placed on the ground, and the question is calculate the pressure exerted by the container. So how to do such question in which you want to calculate the pressure exerted by the container on the surface or on the ground? So to calculate the pressure, we need the force and we need the cross-sectional area. So what area we will take? We will only take the area which is in contact with the ground. So we'll take what area of this object is in contact with the ground, that area we will take. And what about the force? In this example, what force we'll take? The force is actually equals to weight of an object, which is acting downward. So if we want to calculate the pressure, so the pressure will be mg, which is a weight, and divided by, if we have a length and a width, divided by L into W. So for objects which are placed on the ground or on the surface, the pressure exerted is equals to the weight of the object divided by the surface area in contact. The total surface area in contact, that will be the area. If you want to calculate the pressure exerted by the fluid or the liquid, say you have a container which is filled with a fluid, means the liquid is there, and the object is there. Say we have a container. This is the base of the container. So a container is there which is filled with a fluid, and we want to calculate how much pressure is exerted by the fluid. Say the base area of this container is A. The depth of this container is H, or depth of the water liquid also you can say. And the weight of the liquid, this is the center of the gravity, and the weight is acting downward, weight is W. This is if you want to derive a formula for the pressure exerted by the liquid. So we know the formula to calculate the pressure. Pressure is force acting on unit area. So pressure is force divided by area. The force is equals to weight of the liquid divided by area. What about the weight of the liquid? The weight is mass multiplied by gravity. So in place of weight, I can write mass into gravity into area. What about the mass? The mass I can represent in terms of density and the volume. So it will be density multiplied by volume. So in place of the mass, I can write density into volume and divided by area. What about the volume of this liquid? Because this object, like the container, is completely filled with the liquid. So in this example, the volume of the liquid is same as the volume of the container. So what is the volume of the liquid inside? The volume of the liquid inside will be area multiplied by depth. Like this base area, this is the base area multiplied by depth, I'll get the volume. So the pressure is equals to density. In place of volume of the liquid, I can write area multiplied by height or depth divided by area. Because this A will cancel with A. So what it shows that the pressure exerted by the liquid depends on the density, depends on the depth, and depends on the gravity. So the deeper the object inside the fluid, means the liquid, it will experience a high pressure. If a density of the fluid is high, the object will also experience, like the fluid will apply a greater pressure. So high dense liquids or fluids exert more pressure. The deeper we go inside the fluid, it will apply more pressure on us. So pressure exerted by the fluid equals to density of the fluid multiplied by the depth multiplied by the gravity. Is it clear? Any doubt in this? The pressure of the liquids? Any question or doubt till this point? If we apply the same steps on the solid on the flat ground, we'll get the same formula. Yes, if we apply the same steps for the solid, we will get the same formula as well. But so why isn't it applicable on the solid? Yeah, that's a good question, Ahmad. That usually for a solid, pressure is force over area, okay? But why this same formula that the pressure exerted by the fluid depends on density, gravity, and depth is not, we don't apply for solid, we only apply, or we say it's for liquids only. The reason is that because if we have, for example, a solid is there, which is having so this is a solid. This is a base area of the solid, and this is example the height. And I want to calculate the weight of this solid. It's a solid material, like example, all its masses their weight. So if I want to calculate the pressure in this case, I can use this formula that the pressure is equals to density of the solid, gravity, and the height. It will work. But what if the solid, the same solid is there, and the area in contact is different? The same solid, but we change the area in the contact. Now, in this case, I cannot use a formula that the pressure is density, gravity, and depth because the area in contact is different. So if for solid, the area in the contact changes. So there is a solid which is on the ground and you want to calculate the pressure is force divided by area or density, gravity, and the height, it will work. The total area in contact. But for solid, the area in contact can be changed. So if the area in contact can be changed, the pressure exerted by the solid will also change. Like this is the area in contact first, and the other example, this is the only part in contact. So in both cases, even though the weight of the solid is same, like weight is 100 Newton here and weight is 100 Newton here, but the pressure which it will exert, that will vary because the area in the contact will change. So for a liquids, whenever we want, is it clear to everyone? So for a liquid, when we apply the liquid, the pressure depends on the density of a liquid and gravity and depth. That's universal. It means in all the scenarios it will work. The pressure exerted by the liquid on the base of the container. So yeah, I can derive the same formula again, like pressure is force over area, or force is equals to weight and divided by area. Weight is mass multiplied by gravity, so mass into gravity divided by area. Mass is density into volume, so density into volume into gravity divided by area. What about the volume? Volume of the liquid inside. Like example, if this has a base area A, this was having a base area A, and the depth of the liquid was H. So when I substitute, the pressure will be equals to density, the area multiplied by length, that's a volume, into gravity divided by area. Area will cancel with area. So pressure is equals to density, the depth, you can say H or L, into gravity. That's how we work out the pressure exerted by the liquids. Is it clear? Any doubt about the pressure in liquids? So liquid pressure act in all the directions, so it's L equally in all the points on the wall of container. Yeah, so actually what happened is actually a difference in the pressure. Whenever you have a container which is filled with a liquid, say an object is submerged. So there's an object at this position and it is submerged in the liquid. So as a result, the liquid will apply pressure in all the direction. Liquid will apply pressure from the right. Liquid will apply pressure from the left. Liquid will apply, there will be upward pressure from the liquid, and liquid will apply downward pressure. But when we are using this formula that pressure is equals to density of the fluid multiplied by gravity and multiplied by depth. So when we talk about the depth, it's always we are calculating a downward pressure here. So this is to calculate as we go deep inside the fluid, how much pressure exerted by the fluid, the downward pressure that we are calculating. Is it clear? So liquid exert pressure in all the direction. Like, so like if this is representing a wall, so what is the pressure? The pressure will be on towards the right. What is the pressure? The downward. What is the pressure? As you can see, these arrows, the directions are different. So liquid apply pressure in all the direction. So if there's an object in the liquid, it will experience the pressure in all the directions. Because the particles are moving and they're colliding in all the surface, on the surface. As a result, it creates pressure in all directions. So pressure in liquid depends on the depth. So it also depends on, like, deeper we go inside, the higher the pressure we experience. And it also depends on the density of the fluid. Like this a word, this example. Say, what is the pressure on the base of a tank of a uniform cross-sectional area of 4 meters square when the tank is filled with the water at a depth of 5? So there's a tank which is having a uniform cross-sectional area and it is filled at a depth of 5 meters. And the base area is 4 meters square. So how we can work out the pressure, because we know the pressure exerted by the fluid Depends on the density, depends on the gravity, and also depends on the depth. So, and what is the pressure on the base of the tank? Look, there are two pressures always act. Number one, the pressure will be there on the base of the tank. One pressure is there due to the liquid. Like liquid will apply some pressure, and how to work out the liquid pressure or pressure due to the liquid at the base? That is the density, the gravity, and depth. And there's also another pressure, the pressure of the atmosphere. So what will be the total pressure? The total pressure at the base of the tank will be equals to pressure of the atmosphere plus the pressure due to liquid. If the question was just to calculate the pressure due to liquid, we'll just use the density, gravity, and depth. But because we need the total, what is the pressure on the base? So we have to include the atmospheric pressure. So the total pressure will be equals to atmospheric pressure, which is given in the question, 1 exponent 5 or 100,000 Pascal or 1 atm, plus the pressure due to the liquid, which is the density of the liquid. It's given 1000 or 1 exponent 3 multiplied by gravity, which is 9.8, 1 or 9.8 multiplied by the depth, which is 5. So when we multiply like these factors and then add 1 exponent 5, so it will be about 1.49 into 10 to the power 5 Pascal. Is it clear, the first example? Any doubt in this? The first part? Any question or doubt in the first one? Okay. Now the second part, what is the new pressure? Shouldn't only be should be on base should only be only bottom. Yeah, base is the bottom. The base is there at the bottom. That's we calculated the pressure at the bottom, which is due to the atmosphere plus the liquid. The pressure on the base is equals to atmosphere plus the liquid. But why we are calculating both? Why we are calculating both? Because you have a container. Say this is the base of your container. The container is filled with a liquid. So the liquid apply pressure. And in our surrounding, we have atmosphere. So atmosphere is also pushing the liquid. So the total pressure will be the atmospheric pressure plus the liquid pressure that is on the base. So base experience the total pressure due to atmosphere and the liquid. Now, the next part, is it clear, Mohammed Furqan? Okay. The next part, what is the new pressure on the base of the tank when the wood block or wooden block of 1 meter cube floats on the water tank? So there's a wood of volume 1 meter cube, and the density of the wood is given to us. And the question is calculate the new pressure. So actually what happened, this wood will also contribute to a downward, like there will be additional weight of the wood will be there, which will act downward. And that weight will also contribute to the pressure on this base area of 4 meters square. So if you want to calculate the new pressure, we already have the pressure first. Like first what we can do, we can work out the weight of the wooden block and the water. because there's a wooden block which is floating and we want to calculate a new pressure. So first what we do, we'll work out the weight of the total weight, because the weight of the wooden block is acting downward and weight of the liquid is also acting downward. So total weight of the wood plus the water. So how to work out the weight of the wood? We have the density and the volume. We can work out the mass and just that mass multiplied by gravity. Like example, density of the wood is 0.6 exponent 3. So 0.6 into 10 power 3. That's a density multiplied by the total volume of the wood was 1. So it is 1 times the gravity 9.8. That will give us the weight of the wood, because weight is mass times the gravity. And what about the weight of the water? We have the density of the water and we have the volume of the water as well. What is the volume of the water? Because it will be like the depth multiplied by the cross-sectional area. That will be the volume of the water. So the density is 1 into 10 power 3 multiplied by the volume of the water, which is 4 multiplied by 5. 4 is the area and 5 is the depth, and then multiplied by 9.81. What this will give us? This will give us a total downward force will act, like the weight of the water and the weight of the wood. So the total downward force by this formula, why we are taking volume, not area? Because whenever we need the mass is density multiplied by density is equals to mass divided by volume. So mass is density into volume. So, and weight is equals to mass into gravity. So if I need the weight of an object, it will be the mass into gravity, and the mass is density into volume. So we need density, volume, and gravity. So this is also another formula to work out the weight of an object. The density of object multiplied by the volume of object multiplied by gravity, we will get the weight. So this is representing the density, and one was a volume and multiplied by gravity. Here this was a density. Here the volume is area multiplied by depth. So volume and the gravity. So when we multiply, we got the weight of the wood and the weight of the water, and we add to get the total force. So the total downward force which the both wood and the water will exert, that is equals to 2 exponent 5 newtons. Is it clear till this point? Any doubt till this point? The total downward force, or the force which both wood and the water will apply? Okay. Next, we need the pressure. Next, we need the pressures. To get the pressure, pressure is force over area. So force divided by area, what is the total? Because we are calculating the new pressure on the base. So what is the area of the base? The area of the base, the cross-sectional area is 4 meters square. So it will be 2 into 10 power 5 divided by 4. So 2 into 10 power 5 divided by 4. So this will be equals to 0.5 into 10 power 5 Pascal. So the pressure, the total pressure which these two will apply, that is equal, combined pressure of these two will be equals to 0.5 into 10 power 5 Pascal. And there is also an atmosphere. The atmospheric pressure is 1 into 10 power 5 Pascal. So what is the total pressure? So 0.5 exponent 5 plus 1 exponent 5. So we get 1.5 exponent 5 Pascal. That's the total pressure which it will exert now. Is it clear, this example? 7.1. Any doubts? Example 7.2. Example, a vessel is there containing a liquid with a density rho, and it moves vertically upward with an acceleration a. Find the variation of a pressure with depth below the liquid surface Find the variation of a pressure depth when the vessel moves downward and the vessel is falling freely. So first we should draw a diagram for this. So we have a container. Example, it has a cross-sectional area of A. And the depth of the liquid, like it is filled with a liquid. And the depth of the liquid is H. And the first example, because three different scenarios we have, A, B, and C. And the first scenario, it is accelerating upward. Now, what are the forces acting? One is the weight of the liquid, which is acting downward. And another one, the liquid is in contact with the surface, like the liquid is in contact with the surface of the vessel, the base of the vessel. So there will be a normal contact force, or R is acting upward. Now, as I mentioned, it is accelerating upward. So if it is accelerating upward, which force should be greater, R or W? It is going up, accelerating up. Which force should be greater? That's right, R should be greater. So I will write R. R minus weight must be equals to MA. Is it clear? Why I wrote MA? Because it is accelerating upward, so there must be a resultant force. So R minus W is equals to MA, or I can say R is equals to W plus MA. Is it clear? So R equals to, and I can represent this in terms of the, and because according to Newton pair force, the total downward force, so because this R is a pair force of, there will be a downward force. So that downward force balances with the R. Because the forces always act in pair. So what happened when it is accelerating upward? So there will be a downward force. That total downward force balances with the R. R is the normal contact force, which is the reaction force of the downward force. R is not the reaction force of the weight. Don't get confused. Weight and R are different things here. As the object is accelerating upward, there will be a downward force, and that downward force balances with a normal contact force, according to Newton pair force. So means the R and the downward force and the normal contact force will be same. And if we want to calculate this R first, we want to calculate pressure, but if we want to write the expression for the R, R is weight plus mg. What about the weight? Weight is mass into gravity. No, R is not upthrust. R is not the upthrust. R is the reaction force. You have a container. There is a liquid. The container is filled with a liquid. The weight of the liquid is acting downward. So means there is a downward force. Because of there is a downward force, so there will be a normal contact force, R is there. So R is a pair force of a downward force, which in this case is due to the weight. But when it is accelerating upward, there is more downward force, that like the liquid will also push it downward, so that downward force balances with the R. So, and in terms of the acceleration, the R must be greater than the weight to accelerate. So R minus W is equals to MA. So R is equals to W plus MA. And what is R in terms of, because weight is mass multiplied by gravity. So I can write mg plus ma. If I take m common, so if I take m common, it will be g plus a. What about m? If I can represent the m in terms of density, because mass is density into volume. So I can write density into volume, g plus a. And what is volume? Volume is area multiplied by height. So I can say R is equals to density area into depth, G plus A. So that is R is equals to density of the fluid, area of the base, the depth. So volume is area into height, area into depth, and this is G plus A. That is the total upward force, and that upward force will be there will be a pair force, so there will be a downward force. So it means this is also a downward force because R is a pair force of the downward force. So the downward force should also be like this. And if you want to calculate the pressure, so the pressure is force over area. So what is the force exerted by the liquid? The downward force exerted by the liquid, its density, area, depth, G plus A divided by A. So A will cancel with A. So what about the pressure? The pressure will be equals to density, depth, G plus A. So what actually happened that in this case, if the vessel is accelerating upward, what will happen? There will be more downward force as the downward forces increases. As a result, the pressure exerted by the fluid will also increase. So what will the variation of the pressure? If it is accelerating upward, the pressure will increase for the same depth. Is it clear, this example? Anyone having a doubt or a question in this part? Why the pressure has increased? Any doubt? Abdul Rafi, Ammar, Aisha, Iman, Ghulam, Shahid, Saud, Nafal, Shayan, Muhammad Furqan. So as the downward force increase, R also increases. Yeah, the pressure exerted by the liquid will also increase for the same depth. So if you have a container, which is filled with a liquid, the pressure exerted by the liquid depends on the density, gravity, and depth. Okay. So what should happen if this was stationary, if it was not moving, then the pressure with reference to time should remain constant. But you have a container with the same amount of a liquid, and that container is accelerating upward. So if the container is accelerating upward, what we will experience that the pressure exerted by the liquid will also increase as this is accelerating. Means it will experience a higher pressure. Any doubt in this? But aren't they asking variation of a pressure with depth? Yeah, the variation of the pressure with depth. So what actually happened? How the pressure vary with the depth? In part, we are supposed to draw a graph. No, you're not supposed to draw a graph. I just drew a graph to explain the idea. You're not supposed to draw a graph. So what actually happened is weight is acting downward and there is a normal contact force is acting upward. So R minus W is equals to MA. So it means R is equals to W plus MA. So what is actually R? R is a reaction force of the fluid. So if the R has increased, because R is W plus MA, so if the R has increased, it means the downward force is also increased. The downward force by the fluid has also increased because it is a pair force, Newton pair force of a downward. So as a result, if a downward force increase, the pressure exerted depends on the force and the area. Area is constant, but what happened? There is more downward force. If there is a greater downward force, so the pressure exerted by the fluid at a depth h will also increase. Is it clear? what determines the downward force? The downward force depends on the weight plus additional force which we apply. So when the fluid is accelerating, because of its inertia, the weight is already acting downward. Because of its inertia, it tries to resist the change. So the fluid will also apply an additional downward force. So the total downward force will increase. So when the total downward force increase, the normal contact force will also increase. But the pressure exerted by the liquid depends on the total downward force. And in the second example, what is the variation of a pressure with depth if a vessel move downward? So the same vessel and it is accelerating downward. So if it is accelerating downward, the two forces, there's a gravitational pull and there's a normal contact force. So in this case, the gravitational pull should be more than the normal contact force, and that is equals to ma. Or we can say W minus ma is equals to R. So overall, what will happen to the value of the R? The value of the R will decrease. If the value of the R will decrease, the total downward force, because R is a pair force of a downward force, that will also decrease. So the pressure depends on force and area. The cross-sectional area is not changing, but the downward force has decreased, so the pressure will also decrease. So in comparison, if a container which is filled with the liquid and it is accelerating downward, that container will exert like pressure due to the liquid will decrease as it is accelerating downward, because smaller downward force, as a result, the pressure will reduce. How we can add or remove the downward force? Let's take a simple example. When it is at rest, or stationary, example, the weight is 2 Newton. So what is the downward force? The downward force is 2 Newton. So what should be the normal contact force? The normal contact force should also be 2 Newtons. But another example, like this is when it is stationary at rest. Less than a minute left. I'll share another link and I'll explain this example with values so you will have a better understanding. So join from another link.